Rim, am I audible?
Yes,
Rim,
sir.
are you? Okay. So, Rim, you disconnected in the last class, right?
Yeah, sir. I had internet issues.
Okay. Today, all good?
Yeah, sir. Today I won't leave.
Okay. Okay. Thank you. So, basically, in the previous classes, we had completed the preparation of phenols, and then we are going to start today a new topic, basically. First of all, do you have any doubt, or should I just scroll up to the class you haven't got disconnected? So can you tell me on which topic you were when you were connected?
Yeah, sir.
Just
Little bit down. We
little bit
finished
down.
this topic.
We finished this topic. That means basically you were done with this all part.
Yeah, sir.
Okay. So basically, in the previous class we started preparation of phenols, and you know phenol is what? OH is directly connected to this benzene group. So this is phenol. Okay, and we treat phenol as different functional group, and also phenol is known as carbolic acid. So we are going to see the preparation of phenol. So first of all, we are going to prepare it from haloarenes. So as you already know, what is halo? That is X, and arene, that means benzene. Any halogen that is directly connected to a benzene group, that is called haloarene. So I just took chlorobenzene, and we prepared alcohol from chlorobenzene. How we prepared chlorobenzene? So chlorobenzene reacted with alkali part, that means base, at 623 Kelvin and 300 atm pressure. The condition is quite drastic. You can see the temperature is too high and pressure is also too high, because this chlorobenzene is already very stable. So in order to react this NaOH with the chlorobenzene, we need an extreme condition. That this is the extreme condition. And in this, here we got phenoxide ion. Here we got phenoxide ion. And when we treat with HCl, phenoxide ion, you can see this H plus will go to this minus, so it phenol will form, and this Cl, you can see Na and Cl will combine to form a byproduct, that is NaCl, sodium chloride. So this is the first process, or this is the first ways to prepare phenol from haloarenes. So please write it. Since when students will come, then I will start the new topic.
Okay, sir.
Please write it.
Done, sir.
Very good. So we are going to prepare phenol from the next method, that is benzene sulfonic acid. Do you know what is this sulfonic acid? Do you have any idea about sulfonic acid?
Yeah, sir. SO3H.
SO3H, that is a functional group, and in nomenclature we give uh, most priority to this functional group, sulfonic acid. So in order to prepare phenol from sulfonic acid, we need to prepare benzene sulfonic acid first. So how we are going to prepare benzene sulfonic acid? It is very important. When we are going to dip this, when we are going to uh, react benzene with oleum, that is oxy acids of sulfur H2S2O7, then we will get this benzene sulfonic acid, and with this benzene sulfonic acid we are going to react with NaOH first, then phenoxide ion forms in the same way as in the previous benzene O minus Na plus, and then that will be treated with HCl or acid, you can see. So that O minus, with O minus, H plus will go and then form phenol. I think this is clear too. Please let me know when you are done with this. So Rim, where were you? I think you were not present in the last month in class.
Sir, I was in India for vacation.
Okay, got it. Please write it. Let me know.
Done, sir.
Thank you. Very good. So you can see the next method is also very easy, and we are going to prepare with diazonium salt. Do you know what is diazonium salt? This is N2 plus X minus. This is known as diazonium salt. So first of all, in order to prepare diazonium salt, we need to react aniline with nitrous acid. This together is known as nitrous acid. Nitrous acid, NaNO2, in the presence of HCl, that is nitrous acid. So when you are going to react this, there will be a formation of diazonium chloride, that is salt, benzene diazonium chloride, and this diazonium chloride will be reacting with warm water, and then phenol will form along with the evolution of N2 gas, and then another byproduct, that is hydrochloric acid. Please write it.
Sir, aniline is benzylamide, right?
Aniline is what you just said?
Benzenamide.
Not amide. Amide is a different functional group,
Amine,
and
amine.
amine. Yes, amine. You can say that. Thank you. So when your paper gonna happen? Do you have any idea about the test, unit test, exams?
Yeah, sir, I guess I'm having pre-boards in December.
Pre-boards in December. Okay, what is the syllabus? I think.
I guess I have this chapter and few, maybe 5 or 6 more.
So can you tell me which chapter is gonna be there? What will be the syllabus in this week? Or
Haloalkanes will be there.
can I write it down?
What, sir?
I'm writing it down, so please let me know the chapter's name.
Haloalkanes,
Oh, wait a minute. Halo
alcohols,
alkanes, alcohols that is going on. Okay.
and this one, aldehydes.
No, this is not aldehyde. This is basically alcohol, phenols, and ethers. But aldehyde will be there, right?
Yeah, yeah.
Okay. Then
So this much only I know.
you only know about these chapters, right?
Yeah.
Okay, okay. Whenever you will get to know about the paper syllabus, please inform me as soon as possible.
Okay, sir.
Let me know when you are done with this. Are you done with this diazonium chloride? This is the second last method of preparation of phenol.
Yes, I'm done.
Okay, the next preparation comes through amine, biamine, and sorry, cumene. What is cumene? This is the structure of cumene. So basically, how we are gonna prepare phenol from cumene? So it's very easy to understand. We just need to oxidize this cumene. We just need to oxidize this cumene. So O2 will be added in between this carbon and this hydrogen in this way, and this is known as cumene hydroperoxide. And after preparing cumene hydroperoxide, we are going to react this cumene hydroperoxide with acid H plus in the presence of water, then we will get phenol with a ketonic group, that is propanol. So see what happens, this diagram you can see the closed path, this. So with this, it will form ketone and this OH will be directly connected with this carbon, then phenol will be formed. Ayman, are you there? Please write it in rim and then let me know. Then we are going to start the uh, today's new topic, that will be basically chemical reaction. And first of all, we are going to study about the chemical reaction of phenol as well as alcohol. Ayman, are you there?
Yes, sir.
Okay, thank you. So Ayman, why are you late?
Sorry, sir. I was late. I was sleeping.
Okay, okay, no problem. So please try to uh, join the class as per time.
Done, sir.
Okay. So I mean, basically, got disconnected in the last class. So I was just explaining the previous classes topic, and now we are going to start the new topic. That is basically chemical reaction, and it's very important chemical reaction. I think I had given homework to you, Amin, about the NCRT question, exercise question. I mean, did you complete that? Yes or no? It's very
No,
important to.
sir.
That's very bad. It's very important to discuss questions. If you are not going to ask any question, that means basically all the students are not practicing question or whatever. So I today I'm going to give you some homework. So you have to complete, or in the beginning of class, I will discuss that question apart from assignment. Okay.
Okay,
So
sir.
let's start our topic, that is chemical reaction, and we are studying the chemical reaction of alcohol. So first of all, you have to be careful. This alcohol can act as nucleophile as well as electrophile. There will be condition for this electrophile and nucleophile. So everyone knows about what is nucleophile and what is electrophile, right?
Yes, sir.
So please let me know if you are not heard. If you don't know about the term like nucleophile and electrophile, and I think you know about it. So basically, alcohols, or we can write, they react as both nucleophile as well as electrophile. Electrophile. So everyone knows that this nucleophile means nucleus lover. Nucleus, that means basically positive lover. That means basically this nucleophile means a rich electron species. The species which are rich in electron, that they have a lot of electrons, like in in the form of negative charge or lone pair, that is called nucleophile. And do you know what is electrophile? Basically electron loving. That means basically who will love electron, the person or the substance which will not have much electron or sufficient electron, that will love electron. So basically this is electron deficient species, we can say. This is electron deficient species. So this alcohol can act as nucleophile as well as electrophile, but there is condition when it gonna act as nucleophile, when it gonna act as electrophile. What is alcohol? So you know that basically there will be ROH. So this is alcohol. Can I say this is alcohol?
Yes, sir.
So see, what is the difference when it is gonna act as nucleophile? So when the bond is broken between O and H, when this bond will be broken, then this alcohol will be acting as nucleophile. This bond will be acting as nucleophile. So I can write the bond between OH is broken when alcohols react as react as nucleophiles. When alcohol react as nucleophiles. Everyone knows that basically hydrogen is very less electronegative than oxygen. So how the bond broken, the nature of breaking of bond here will take place. So basically what will do, oxygen will take electron from hydrogen. So you can see it will become RO minus. And you can see what is nucleophile. Nucleophile is electron rich species in the form of either lone pair or negatively charged. Now you can see this alcohol converted into negatively ion. That means anion. So it has negatively charged. That means two more electrons. So it can donate easily. That's why it acts as nucleophile. Is that clear to everyone?
Yes, sir.
So alcohols as nucleophile, I'm gonna write the reaction. So the first step, you can see only the first step. This is the structure of alcohol, and there is what? There is basically an electrophile. So when nucleophile will act, whenever there will be electrophile nearby, whenever a substance present nearby which has lesser number of electron. So what it will do? So basically this will attack here. You can see this will attack here. So what will happen here? R O, then hydrogen will be with oxygen, but on oxygen there will be positive charge, and you can see like this. Now, can you tell me, this is very important point. Do you know positive charge is positive charge is stable or unstable on oxygen? Do you know positive charge on oxygen will be stable or not? Stable or not?
No.
No. See, there is a very simple trick. The elements or the substance which is very electronegative, that means more electronegative. So always remember that electronegative negative charge on electronegative elements are more stable. Negative charge on, I'm gonna write it, negative charge on more electronegative element, more electronegative element is stable. So you can see that basically there is positive charge on oxygen, and oxygen is the second most electronegative element. So that means it is unstable. So in order to get stabilized, what it will do? It will take electron from hydrogen to stabilize itself, and there will be the product formation. You can see ROC, and it will be like this, and H plus will be eliminated. Is that clear to everyone?
Yes, sir.
So it can be asked like this: C plus O plus. Which one is more stable, Ayman? Can you tell me which one is more stable, C plus O plus?
Sir, C plus.
C plus, because carbon is less electronegative than oxygen. So it's very obvious oxygen is very less stable than carbon, because positive charge present on both, and whoever is the less electronegative will be more stable. And converse is also true. Positive charge on less electronegative element is stable. So please write this and let me know when you are done with this. So when alcohol acted as nucleophile, this is the situation. Then we will see how it will act as electrophile.
Done, sir.
Very good. Ayman, are you done with this? Ayman, please do respond. Can I change the slide, Ayman? Rim, do you know what is protonated alcohol?
No, sir.
Do you know what is protonation? Protonation. Just let me know if you don't know. These
No,
terms are
sir.
similar. Okay, so see, whenever there will be a term like ation in the end, like hydrogenation, chlorination, that means addition of that. Halogenation, that means addition of halogen. Hydrogenation, that means addition of hydrogen. Hydration, that means addition of water. Chlorination, that means addition of chlorine. And if there is a term protonation, that means addition of rim. Protonation, can you tell me now? Rim, can you tell me now what is protonation? What you just said, your voice is lagging.
Addition of protons.
Addition of proton. That means proton means H plus because it is the only one electron will be the, no electron will be there. So H plus is proton, yes or no?
Yes, sir.
Very good. Now the next point is very easy. I'm going to explain. I think Amon's network is not good, so that's why he's not responding. Amon, please let me know when you are done with this. Now see, we just completed alcohol acting as nucleophile. Now the next point, you saw that this is alcohol. So when this bond will be broken, alcohol will act as nucleophile. But when this bond will be broken, C and O, between the bond C and O, if it will be broken, it will be acting as electrophile. This is nucleophile and this is electrophile. So I'm going to write a point. You can see the bond between CO is broken. The bond between CO is broken. When they react as electrophiles, but there is a condition in here, and the condition is it should be protonated alcohol. Protonated alcohols react in this manner. React in this manner. That means first the alcohol will be reacting with proton, and then that alcohol will be acting as electrophile. So I'm going to write this. It's very easy. Protonated alcohols as electrophiles. It's very easy. I mean, you can reply me in chat box.
Yes, sir, I'm here.
Okay. Did you write all this?
Yes, sir, I'm
Okay.
writing this.
Now
one.
see. Okay. Wait a minute. Just focus here. Then you will write. So first
Okay,
of
sir.
all, we need to react this alcohol with the proton. That means H plus with the proton. This is I'm going to do protonated protonation. Okay. So you can see oxygen has lone pair. So this will attack here and it will form RCH2 and there will be OH2 plus. In order to understand, you can see this oxygen has lone pair and oxygen making two bond OH and with C, H with C, H and C with H and with C. Now this hydrogen will be connected and it will be like this. Now this alcohol became like RCH2. You can see, wait a minute. Just let me slide it up slightly, then you will get it. Now see. So I'm going to write this CH2, OH2 plus, and here it will be R. Can I write this as this? And if there is any nucleophile, you can see what happens since oxygen is less electronegative when it has positive charge. So what it will do, it will take electron from carbon in order to stabilize itself and it will form H2O and eliminate from here. Now when oxygen will take electron from carbon, this carbon will having deficiency of electron. So in order to stabilize it, this bromine, since it is electrophile, it has negative charge. That means it is electron rich species. So it will attack this carbon and there will be a bond formation of BrCH2R. So you can see in this way, alcohol can act as electrophile and only protonated alcohols will act as electrophile. Please write it.
Done, sir.
Very good. Ayman, let me know when you are done with this, please.
Yes, sir. I'm also done.
Okay, thank you so much, both of you. So see, do you have any doubt in this?
No, sir.
Okay. So
No,
see,
sir.
when we are going to study about the chemical properties, first we are going to divide it because there will be two types of chemical properties. When the bond between OH will be broken and when the bond between CO will be broken. So first of all, today we are going to start a very simple chemical reaction, that is involving reactions involving cleavage of OH bond. And after completing this, then we will start reactions involving cleavage of CO bond. Are you getting my point? Rim and Ayman.
Yes, sir.
Yes, sir.
Okay. So see, I'm going to ask you a very basic question from class 10. When acid react with metal, what was the product in class 10? Can you tell me the product? You have studied it in class 10th. Acid plus metal is what? Do you remember? Do you still remember it?
No, sir.
Okay, so Rim, what about you? So it is basically
I
salt
don't either,
plus
sir.
hydrogen gas. Salt plus hydrogen gas. Like if I'm going to tell you that when magnesium that is metal gonna react with HCl, there will be formation of MgCl2 and evolution of hydrogen gas. Pop sound. You have heard of it in class 10. So this is salt and this is hydrogen gas. Is that clear? Is this
Yes,
clear
sir.
to both of you? Now see. First of all, we are gonna learn about acidity of alcohols and phenols. Acidity of alcohols and phenols. So first of all, you have to be careful. This acid and phenols are acidic. These acids and phenols are acidic in nature. That means it gives H plus. That means basically they are acid. And when alcohol is gonna react with metal, there will be the product formation, that is salt with evolution of hydrogen gas, because it is also acid, right? And when acid react with metal, then what happens? Salt and hydrogen gas formation takes place. Is that clear? Please do
Yes, sir.
please do respond. Thank you. So this is basically reaction with metals. We are gonna react this alcohol and phenol with metal. Reaction with metal. So as I already told you, if this is ROH, alcohol, and you are gonna react with Na, sodium, what happens here? Hydrogen will be eliminated and evolve, that we are gonna take 2 moles. And what happens? H will be replaced by Na, that means RONA. So in order to balance it, just make it 2, just make it 2. And this is our salt and this is our hydrogen gas, evolution of hydrogen gas. Is that clear?
Yes, sir.
So please write it and let me know when you are done with this. Let me know when you are done with this.
Done, sir.
Very good. Ayman?
Acid is formed.
Okay.
Yes, sir, done.
Very good. So this was the first example of alcohol reacting with metal. I'm going to take another example, and you know what? Can you balance the reaction and write the product? CH3, COH, CH3, CH3, and this is aluminum. This is 6 more. This is, I'm going to take 2 more. So please write the product. I'm waiting. Are you done with this? So see, it's very easy. Just remove this hydrogen and do it here. Like it is CH3, C, CH3, and there is CH3, and there will be O and then A, and just make it like this. And it will be here, it will be 2, and here it will be 3 in order to balance it. And then this is salt and hydrogen gas will be evolved 3H2 because you can see 6 hydrogen is there. So 3 mole of hydrogen will be evolved. Is that clear?
Yes, sir. Okay.
Okay, now see alcohols. We just saw the alcohol's acidity. Now, basically, the phenols also react in the same manner. Like if you have this phenol and you are gonna react this with sodium, what you need to do? Just replace this H with Na. Then you will get this ONA. This is known as sodium phenoxide. This is known as sodium phenoxide. And there will be evolution of hydrogen gas H2. So in this way, we prepared this or we did this reaction. And in the same way, in the previous question, RIM, in the reaction, I told you sodium phenoxide, that sodium phenoxide. Okay, phenoxide, and I think I told you. Just replace that with sodium phenoxide. Let me know when you're done with this. Are you done with this?
No, sir.
Done, sir.
Very good. Ayman, are you
Yes, sir.
also done
Done.
with this? Okay, so you also studied it in class 10th. Then, when acid react with base, what happens? Can you tell me the product? Salt plus water. Neutralization reaction. Now, do you remember it? Rim and Ayman.
Yes, sir.
Okay, so please do this question for me and let me know the product name. You can write it. This is acid, you know that, and I'm going to react this with base. Please let me know the name of the products. Are you done with this?
Sir, it will be Na plus H2O.
Na plus H2O. This Na is going to replace this H. Then a salt will form that will be known as sodium phenoxide. This is the salt. And you can see H and OH will combine to form H2O. Rim. Everyone done with this?
Yes, sir.
Okay. So I'm going to ask some question. So please arrange in increasing order of acidic character. Can you do this question? Let me know if you are unable to solve it. Please let me know when you are done with this. Are you done with this? Aman, Reem.
No, sir, I can't solve it.
So see, uh, Aman, it's very easy and simple trick. You have studied this in class 11th, GOC, General Organic Chemistry, and how we are going to approach it. Whenever there will be question on this acidic and basic character, there is a simple formula. If we are going for acidic character directly proportional to minus R, which is directly proportional to minus R, which is inversely proportional to plus I and inversely proportional to plus I. Do you know what does this minus I and plus I stand for? What does this minus R and plus R stand for? Yes or no? Please tell me frankly, both of you. Do you have any idea about this negative I? That means basically negative inductive effect. I stand for negative, inductive effect, and this is basically positive inductive effect. And you can see this is basically negative resonance or mesomeric effect, and this is positive resonance. Is that clear to everyone? The name?
So you can
Reem,
repeat it again. I didn't understand.
this I stand for inductive effect, and negative, that means negative inductive effect. This is positive inductive effect. This is R for resonance, negative resonance and positive resonance. Am I clear to now? Am I clear to you now?
Yes, sir.
Now, what you need to understand is what is this minus I minus R and plus I plus R. So basically, this negative I means negative inductive effect means electron withdrawing group. Electron withdrawing group. So you have to be careful when you are gonna do questions according when you are gonna do questions on acidic and basic character. Just simple remember this, okay? And positive inductive effect, that means electron donating group. Electron donating group. So it's very easy. As for example, CH3. This is electron with donating group. Electron withdrawing group like fluorine, chlorine, and you can say NO2. These are all electron withdrawing group. What about resonance? You have seen two types of resonance basically. If you have a chlorobenzene, like this, in the previous chapter, you have done this resonance of this. Ayman, have you done the resonance of this? I think you have done this.
Yes, sir. I have.
So this chlorine was getting like this. So this will be acting as plus R and this will be acting as minus R. Are you getting my point? Whoever giving electron towards its someone else, so that will be plus R, and who are taking electron, that is minus R. So basically you can see if you are gonna do the resonance of this NO2, you know what will happen? The benzene ring will broken and it will go. So this NO2 will be acting as minus R. Are you getting my point? What is plus
Yes,
R?
sir.
What is minus R? So now
Yes,
you
sir.
just have, very good. Now you just have to be careful. R, that means alkyl group. That means alkyl group, and alkyl group has plus I effect. So you can see this will donate electron. And if it is gonna donate electron, that is acting as plus I effect, that means acidic character is inversely proportional to plus I. In the first compound, you can see only one R was there to donate electron. In the second compound, you can see two alkyl group are there. And in the third, you can see three alkyl group are there. That means the lowest acidic character will be this compound. Are you getting my point? Because acidic character inversely proportional to plus I. So it has more plus I effect. That means it has the lowest acidic character, least acidic character. Amen.
Yes, sir.
Got it or not? Still any confusion?
I think so, sir.
Okay. Do you think so? What do you have any confusion about this?
No, sir.
Think about it. Let me know when you are done with this. I'm gonna give some questions to you. Okay, what about you, Reem?
I don't have any doubts, sir.
Thank you, both of you. Please do it and let me know when you're done with this. Then I'm gonna give some questions. Okay. Please write it and let me know when you are done with this.
Done.
Very good. Ayman, are you done with this? Ayman, please do respond. Okay. So moving to the next slide, I'm gonna give you a question on the same topic. That is to calculate the uh, acidic order. So the question is basically very easy. Arrange the following. Arrange the following compounds in increasing order of their acidic strength. So you are gonna do this question. Please go through it carefully. Propane 1 all. First, you are gonna write the structure of this compound. 2, 4, 6. Trinitrophenol. Then 3-nitrophenol. Then 3, 5. Dinitrophenol. Then only phenol. Then 4-methyl phenol. So the trick in the question is simple. Acidic character directly proportional to -I minus R plus inversely proportional to +I and +R. And the question is that you just have to be careful about -I plus I minus R plus R. So please attempt it and let me know when you are done with this.
Sir, the increasing order begins from 236 trinitrophenol, then 35 dinitrophenol,
236.
346.
I gave you 2 comma 4 comma 6, right?
Yeah, sir, that.
So that means basically it is the lowest. Are you telling me this? This is the lowest. It has the lowest acidic character.
Yeah, sir.
So do you know? Have you draw the structure of this?
Yeah, sir.
So I'm gonna draw the structure first. So this is our CH3 propane 1-ol. That means CH2 CH2OH. Do you know what is this phenol? That means you are gonna write the structure as this phenol. And with this, with respect to this is the second position in which at which NO2 is connected. Third and fourth position is here, and then fifth and sixth position is here. Now with this, you can see phenol at the end. That means main functional group. This is the phenol. With respect to H, you can see 3-nitrophenol. That means NO2 is here. Now 3,5 dinitro. That means I'm gonna show you. This is OH, and this is basically NO2, third carbon, and this is fourth carbon, right? Wait a minute. 1, 2, 3, 4, 5. Fifth carbon. And then after this phenol, you can see this is phenol only. So, am I audible to you?
Yes, sir.
Okay. So both of you concentrate here now. So phenol, you know that this has a structure OH. This is phenol. Now 4-methyl phenol. That means you are going to write the structure. Phenol with respect to OH, it should be at fourth position. So 1, 2, 3, 4. This is, have you drawn the same structure as I did right now?
Yeah, sir.
Ayman, what about you? Are you done with the structure?
Yes, sir.
Okay, now see what I told you about acidic character. What I told you about acidic character is directly proportional to minus I and minus R, inversely proportional to plus I and inversely proportional to plus R. Was this my term?
Yes, sir.
Now tell me, do you know what everywhere most of the in most of this compound NO2 is there? Yes or no?
Yes.
Now
Yes,
tell
sir.
me, what is the characteristic of NO2? Minus I. plus I, minus R, or plus R? Can you tell me, Rim and Aman?
Minus I.
Minus I. And what about plus I and plus R, between plus I and plus R? Aman, can you tell me what is its what its nature? So in the previous question, I have shown this diagram of resonance, and you can see I told you that this bond will be like this. So that means NO2 is minus R. Yes or no?
Yes, sir.
So acidic character directly proportional to minus R. Now you can see it has one NO2, it has two NO2, it has three NO2, it has, sorry, it has two NO2, and now it has three NO2. Which one will have greatest power of minus R? This will have, because it has three NO2 group. That means from three side, it is there will be minus R. Yes or no, Rim?
Yes, sir.
So acidic character directly proportional to minus R. That means in all of these, the most acidic will be the B. Are you getting my point?
Yes,
Yes,
It's
sir.
sir.
directly proportional. What about you, Aman?
Yes, I understand.
No, now, so first of all, you have to be careful about this. So I'm gonna write it as B as the most. What about this? After this will be, then
Yes, sir.
A, B, C, D. After this, which will be this? So it will be C. Now, we are going to decide from this. Now, you should know phenol is more acidic than alcohol. Phenol is more acidic than
Alcohol.
alcohol. And also, I told you that acidic, what is the character of this CH3? Rim, what is the characteristic of this CH3 nature? Plus I, plus R, minus I, minus R.
Minus I.
Minus I told you, I have written this in plus I. CH3, electron donating group, plus I. All alkyl group, plus I. I also wrote here. Alkyl group, methyl, ethyl, propyl, butyl. Are you getting my point, Rim and Ammon?
Yes,
Yes,
sir.
sir.
Now see, it's very easy to understand. Now, can you compare this? Phenol, as you know that this is lowest acidic because phenol is more acidic than alcohol. Okay. So can you tell me E and F, between E and F, which one will be more acidic?
Sir, E.
Between E, E,
E.
because it is decreasing its acidic character. See, this CH3 group is decreasing its acidic character because it has plus I effect. So then E, and after this, what will be then F, and after this E. This is the decreasing order, and you can do this in increasing order, right? Just do the opposite. Yes or no?
Yes, sir.
So please write it. Let me know when you're done with this. Are you done with this?
No, sir.
Okay, take your time.
Done, sir.
I mean, are you done with this?
Almost done, sir.
Okay, let me know when you're done with this.
Yes, sir, I'm done.
Very good. Now, do this question. I'm gonna give you. So there is O-nitrophenol, then M-nitrophenol, and then P-nitrophenol. Please do it. Acidic character.
Sir, what is P, O, and M?
Orthopara meta.
Okay,
Orthometa
sir.
para. Just draw the structure first. Are you done
Sir,
with this?
P,
Yes.
O, and M in decreasing order.
P, O, and then
M.
very good. Para is the most acidic, right? So,
Yes, sir.
are you done with this, Aman? Aman, are you there?
Yes,
So you
yes,
can
sir.
see this is with respect to this. This is our orthonitrophenol, and then with respect to this is our metanitrophenol, and with respect to which this is our paranitrophenol. This is our paranitrophenol. So basically all have same. First of all, this and this almost same basic acidic character, only a slight difference. And this has a large basic acidic difference because at meta position only inductive effects operate, not resonance effect. And resonance effect, we give priority to resonance effect as compared to inductive effect. Are you getting my point? At this meta position, only inductive effect takes place, no resonance takes place. Okay, so the most acidic is basically this one. This one is the most acidic, and then this second, and this then this third. Is that clear?
Yes, sir.
Yes, sir.
So this is it for today. We will continue in the next class. Please do the NCERT exercise question, the of the previous chapter, both of you. First, we are going to discuss
The
it, and
entire
then
question, sir.
yes, the entire chapter. Okay, I will discuss in the next class. Is that clear
Okay,
to
sir.
both of you? Thank
Yes,
you.